Hi everyone, this video is all about kind of simplifying or dividing algebraic fractions. There are three methods to do this. The first one is kind of the traditional algebraic long division method this way, which looks very much like regular number division, where you write what you're dividing in here, and you're writing your quotient, your divisor in here, very similar to numbers, and we could go through that later, but that's method kind of one. There's another method, comparing coefficients, so we're saying that x cubed plus 3x squared minus x plus 1 could be the same as x plus 3 times some, because we have a cubic here, times some quadratic, which is normal. I think you would have used this method in your AS classes to factorize cubics. But we just have to remember we're going to have, this time perhaps, a remainder, and that's going to be in the form of a regular constant. And this is because you can see that this constant here, this constant here is always going to affect the x term. So if this thing doesn't divide exactly, or I can't write x plus 3 times ax squared plus bx plus c exactly this way here, what I'm going to get is I'm going to get a number, because I'm going to get 3 lots of c here, which isn't going to match this plus 1 and this plus d. That's what this is for. This is to correct this plus 1 difference. Again, another method that we could show you. That's method 2. And the third method is kind of a hybrid of the two, and this is the one that I really like. So I'm going to go through this one. Right, so let's do this problem. This really does just kind of take practice. But first off, why do we even want to bother do this? Well, the reason why is because at the moment we can't really integrate this thing. It's very difficult to integrate. And if we could split this thing up into smaller pieces, then we can put this into a form that we can integrate. What we're going to end up with, and you'll see later, is kind of a C2 integral here, plus some constant or something over x plus 2, which, when you find out how to differentiate, you'll realise it's just a simple Lund problem. So why would we want to split this fraction up into lots of pieces? Well, because we can integrate it and differentiate it easier. Whereas before, when we were putting fractions together, that's useful when we're trying to solve an equation. Okay, so that's why we're doing this. Now, the concept behind this is, this method 3, is that what we're trying to do is we are trying to come up with, if we could factorize this, cubic, so it has x plus 2 as a factor, what would that look like if we could put that into two brackets as close as possible to making this thing here? So x plus 2 times this thing, which I know needs to be a quadratic because x times x squared is the only way I'm going to get x cubed. So this thing times this thing here needs to match this as close as possible. If it's impossible for that to happen, then that's when we're going to have a remainder term here. And so previously, when you've been factorizing cubics and all that kind of stuff, you haven't had a remainder. And that's what the step up to C3 is, I suppose. We're going to divide this thing, we probably will have a remainder, and we're going to find out what that is. So let's get this structure going. We're always going to write our denominator here keep the denominator, and we're going to write it in the numerator as well. And then we're going to find out what we need to times this thing by to make it look like this. And this is what this working section is for. So this helps me keep track of where I am. So first off, I need to try and make x cubed. So the only way for me to make an x cubed is if I times this bracket out by x squared. So what I'm going to do with this working section is, if I was to leave this thing as it was and multiply out those two brackets, I would get x cubed plus 2x squared. How does that compare with what we have? Well, we have an x cubed, So this is therefore fantastic. We're now going to look to the next section, so the next power. We've got 2x squared here, but I didn't start with 2x squared, I started with 3x squared, so I need to add another x squared somehow. Again, how can I generate x squared looking up here, while I would need to times, or what would I need to times x by, this x by, to generate that x squared, while I'm going to need to times it by plus x. So again, I'll multiply out what I have to check what the status is. So I'm going to have plus x squared plus 2x. Consolidate my x squareds. Do I have 3x squared? Yes. So this is all good. We're now looking to the next power, 2x. So I have 2x. I need minus x. So I need to get rid of 3x. So what do I times x by to get rid of that? Minus 3. So again, I'll multiply that out. I'll get minus 3x minus 6. Yes, 2x minus 3x does make minus x. But see, I'm left with this minus 6. If I were to multiply out these two brackets as they were, I'd be left with minus 6. That's not what I started with. I need a plus 1. So all I can do is adjust and say I need to add a 7 for what I start to this thing here in order to make this minus 6 plus 1. And see, I can't fit any more into this bracket because the lowest thing I can get, or lowest thing I control, is when our power of x here is 0. You notice we're going down in powers. And notice that my remainder is always going to be a constant in this case when our divisor, our quotient, is a linear, so i.e. the power of x is 1. Minus 3 times x is always going to give me, or whatever number I put in here, times by x is always going to affect the x values. Now why is this method so nice? It's because now you can see this is the same as x plus 2, x squared plus x minus 3 over x plus 2, plus, and if I split up that top, plus 7 over x plus 2. Notice here, this cancels down, that's gone, and we are left with our C2, if we were to integrate this, looking integral plus this thing, which would be easily integrable, it would be in the form of ln. So, we'll do some more examples now. So let's go again. This time we've got over a quadratic function. So we do what we did before. We're going to write the divisor, the quotient, the denominator, whatever you want to call it, top and bottom. We've got a w for our working section. So I need to generate, if I was to times out, a 2x cubed. How do I get that from an x squared? Well, I need to times that by a 2x. In my working section, I'm looking at what I have. Currently I have 2x cubed, that's all good. I do have a 2x cubed. I have no x squared here, I have no x squared here, so that is all good. Here I have, so if I was to look at this in this bracket here, what do I need to times x squared by to get 0x squared? Well, it's 0, isn't it? So in a sense, I don't have to write this every time, but can you see, really, I'm putting plus 0 in here, because I'm saying x squared's all good, top and bottom, I need to make no change. So I can put a plus 0 in there, and as I was saying before, all you can do, once this thing is your constant, all you can do now is deal with your remainders. Everything else is a remainder. So here I have minus 2x, here I have plus 3x. So I need to add 5x. Remember, if I want to multiply out these two brackets, I want it to match as closely as possible to this. And notice that if this is a constant, whatever constant you put in there is going to mess up your x squareds. So everything below x squared is going to be in your remainder. So if this is a quadratic, in here will be a linear. If this is a cubic, this will be a quadratic, etc. So we have 5x now, so plus 5x, that gives us all good, that gives us our 3x, we're happy with that. And here we have plus 0, but here we have minus 1, so we need to minus 1. And again, now I can just very quickly say that this x squared minus 1 cancels here, and I'm left with an x squared minus 1 on the bottom here. So I get plus 5x minus 1 over x squared minus 1, and we're happy. Most important now, how do we check that we're right? How do I know that what I've just done is good? I mean, think about it. Anytime, you don't need to ask your teacher whether you're right. You don't need to look at any answers. You know, you can do all this by yourself by checking with your calculator. How do you do that? This is going to really help you gain confidence. Imagine in your exam as well. If you just put this in, you're doing your exam, you find out that you are absolutely correct. What confidence that is going to give you to carry on. Now, C3 and C4 is riddled with checking mechanisms. You can check about 90% of C4 absolutely if you have the right calculator with a calculus button. And this in C3 is one of these things that you can check as well. How do we do it? Right, so 0.01 in your calculator, press equals, and you have answer. You're going to use this answer button in your starting fraction here. So if I do 2 answer cubed minus 3 answer, plus 3 answer minus 1 over answer squared minus 1, you should get 0.9700950095. I'm now going to do the same 0.01 and whack that in here, and it should match. And I whacked it in my calculator and it does, so we're happy. It's brilliant, it works. You know you've just done some great maths there. Okay, last example. So this time we've got a quadratic on the bottom, but we're not going to let that worry us. That's no problem at all. So same setup, working section, 2 brackets. So this time we've got a 2x to the 4. What do I need to times our x squared by? 2x squared. Multiply out, see what we have. So 2x to the 4 plus 4x cubed plus 2x squared. Our 2x to the 4, we're happy. Here we've got a plus 4x cubed. Here we have no 4x cubed. So we need to subtract 4x cubed. How can I do that? Well, I would need, what would I need to times x squared by to subtract 4x cubed? Well, I'm going to need a minus 4x. So multiply that out. Minus 4x cubed minus 8x squared minus 4x. And look, our x cubes are all sorted. We have none of them now. Everything's all good. Let's consolidate what we have so far with our x squared. So we have minus 6x squared minus 4x. It's just tidying that up to see what we have. So we have minus 6x squared. We need no x. We need no x squareds. So we need to times our x squared by plus 6, and this would give us, if I multiply it out again, plus 6x squared plus 12x plus 6. So the x squareds are all good. We're happy with that. Consolidate again what we've got because it's getting a little bit messy. So minus 4x plus 12x is 8x. And we still got our plus 6. So we have 8x, we need 1x, so we're going to need to subtract 7x, because remember, everything beyond the constant has to be our remainder term. And here we have plus 6, here we have minus 7, so we're going to need to minus 13. So our final answer is 2x squared minus 4x plus 6. Plus, I always recommend that you put your remainder just in brackets and wouldn't try and be too clever with your minus signs, because lots of people get that wrong. Not that you shouldn't do it, but you just need to understand what you mean if you put a minus instead of that plus. So think about it after you've put your remainder term in there. And again, what we'll do is, because no way I'm finished, I'm not finished because I might have made a mistake. So I want you to check for me. So we're whacking x is 0.01, use our answer button. If I quickly do that, you do it at the same time, so let's do it. We'll whack that in the top, 2 answer to the 4 plus answer minus 7 over answer squared plus 2 answer plus 1. This gives us minus 6.8522693666. Do the same for this, our final answer. So 2 answer squared minus 4 answer plus 6 plus minus 7 answer minus 13 over answer squared plus 2 answer plus 1. And we do get minus 6.852269366. So we're happy. That's good maths.